Let's start with the basics. Computer hardware refers to all the physical components that make up a computer system. Unlike software, which is the set of instructions and programs, hardware is everything you can touch, like the case, motherboard, and keyboard. Hardware and software work hand in hand to perform tasks from browsing the web to editing photos. Hardware is typically divided into categories such as power, logic, like the motherboard, and CPU, input, output, and storage. Understanding these categories helps you see how each part contributes to the overall function of your computer. In this video, we'll break down each major hardware component and explain its role. Every computer needs a reliable source of power, and that's where the power supply unit, or PSU, comes in. The PSU converts the alternating current AC from your wall outlet into the direct current DC voltages required by your computer's components. It delivers stable, regulated power to the motherboard, drives, fans, and more. When choosing a PSU, you'll want to consider its wattage, efficiency rating, and whether it has modular or non-modular cable. The number and type of connectors are also important, especially if you have a powerful graphics card or multiple drives. Good cooling and ventilation are essential for a long-lasting PSU. Motherboard is the central printed circuit board that connects all your computer's hardware. It hosts the CPU socket, RAM slots, expansion slots, and a variety of ports and controllers. The motherboard's chipset manages data flow between the processor, memory, and peripherals. Key features to look for include the type of chipset, BIOS or UEFI firmware, power phases for stable CPU delivery, and the form factor, like ATX or micro ATX. Expansion slots such as PCIe and M.2 allow you to add graphics cards or fast storage. Onboard ports provide connections for USB devices, audio, and networking. Ports and slots are essential for connecting both internal and external devices. Ports are the connectors you see on the motherboard or case, such as USB Type A and Type C, HDMI, DisplayPort, Ethernet, and audio jacks. SATA and M.2 ports are used for connecting storage drives. Inside the computer, slots like PCIe are used for expansion cards, graphics, sound, or network cards. RAM slots hold your memory modules, and M.2 slots are for high-speed SSD. Understanding the difference between ports and slots helps you upgrade and troubleshoot your system more effectively. Input devices are how you interact with your computer and send it commands or data. The most common examples are the keyboard and mouse, but there are many others. Touchpads and trackpads are popular on laptops, while joysticks and gamepads are used for gaming. Scanners, microphones, webcams, and styluses or graphics tablets expand your input options. Each device translates your actions into signals the computer can understand, making it possible to type documents, play games, or participate in video calls. Output devices take information from your computer and present it to you in a usable form. The most familiar output device is the monitor, which displays images and text. Printers produce physical copies of documents, while speakers and headphones deliver audio. Projectors can display your screen on a large surface, and LED indicators or status lights provide quick feedback. Each output device is designed to make the data processed by your computer accessible and understandable. Storage devices are responsible for keeping your data safe, even when the power is off. The traditional hard disk drive (HDD) uses spinning magnetic platters and read-write heads, with technologies like perpendicular magnetic recording (PMR) and shingled magnetic recording (SMR) improving capacity. Solid-state drives (SSD) use flash memory with no moving parts, offering faster speeds and greater durability. SSDs come in SATA, NVMe, and M.2 formats. Other storage options include optical drives, CD, DVD, Blu-ray, USB flash drives, memory cards, and hybrid drives that combine HDD and SSD features. Even the best hardware can fail. Common issues include power supply problems like no power or random shutdowns, often detected by using a PSU tester or multimeter. Motherboard failures might show up as no boot, dead ports, or burnt capacitors, which you can spot through visual inspection or BIOS error codes. RAM issues often cause blue screens or system hangs, and can be diagnosed with tools like MemTest86. Storage devices may fail with data loss or slow performance, while graphics cards can show display artifacts or crashes. Cooling failures lead to overheating and loud noises. Detecting hardware failures early can save you time and money. Start with a visual inspection. Look for bulging capacitors, burnt parts, or loose connectors. Many motherboards use BIOS or post-beep codes to signal specific failures. Software diagnostics like MemTest86 for memory or Crystal Disk Info for drives can help pinpoint issues. Monitoring smart attributes on drives gives you insight into their health. Stress tests for the CPU, GPU, and memory can reveal instability, while event logs and reliability monitors in your operating system can track hardware error events over time. Preventive maintenance is key to keeping your computer running smoothly. Regularly clean your hardware to remove dust and maintain good airflow. Use stable power sources such as an uninterruptible power supply (UPS) or surge protectors to protect against electrical issues. Keep your firmware and drivers up to date for optimal performance and security. Invest in quality components, especially for the power supply and cooling. Handle and mount hardware carefully to avoid damage, and always back up critical data to prevent loss in case of failure. Selecting a power supply, understanding its specifications is crucial. Wattage indicates how much power the PSU can deliver, with common values like 500W or 650W efficiency ratings, such as 80 plus bronze, silver, or gold, show how effectively the PSU converts power. Modular PSUs let you attach only the cables you need, reducing clutter. The number and type of connectors matter for compatibility with graphics cards and drive. Good cooling and ventilation help extend the PSU's lifespan and ensure stable operation. Let's take a closer look at motherboard features. The chipset, sometimes split into Northbridge and Southbridge, manages communication between the CPU, memory, and peripherals. BIOS or UEFI firmware controls system startup and configuration. Power phases and voltage regulator modules (VRMs) ensure stable power delivery to the CPU. Capacitors and regulators help maintain reliability. The form factor, such as ATX or ITX, determines the board's size and compatibility. Expansion slots like PCIe and M2 allow for upgrades, while onboard ports provide connectivity for USB, audio, and networking. Storage devices come in many forms. Hard disk drives (HDDs) use spinning platters and are known for large capacities at lower costs. Solid-state drives (SSDs) use flash memory for faster speeds and better durability, available in SATA, NVMe, and M2 formats. Optical drives like CD, DVD, and Blu-ray are less common today but still useful for some tasks. USB flash drives and memory cards offer portable storage, while hybrid drives (SSHD) combine the best of HDD and SSD. Choosing the right storage depends on your needs for speed, capacity, and reliability. Variety of input and output devices available today is impressive. For input beyond the standard keyboard and mouse, you have touchpads, trackpads, joysticks, gamepads, scanners, microphones, webcams, and styluses. Output devices include monitors, printers, speakers, headphones, projectors, and even LED indicators. Each device is designed for specific tasks, whether it's gaming, creative work, or communication. Knowing your options helps you build a setup that fits your needs, whether for work, study, or play. Wrap up: understanding computer hardware is essential for building, upgrading, or maintaining a reliable system. Each component, from the power supply and motherboard to storage and input-output devices, plays a unique role. By learning how these parts work together, how to detect and prevent failures, and how to choose the right specifications, you can ensure your computer runs smoothly for years to come. Remember, regular maintenance and quality components are key to a trouble-free computing experience.